Hi friends, this is Rishi and welcome to Science with Rishi, your favorite YouTube channel. So, in the last video, we were discussing about how to determine the number of significant figures in a number using a set of rules, right? And I hope that is clear to you. And in this video, we are discussing about the rules regarding these significant figures when you are doing arithmetic calculations. Okay, so shall we start? Let's start with rounding off. And let us study all this with these 4 examples. It's a very simple topic. Okay. So I have been asked to round off these 4 numbers to the second decimal place. Okay, to this second decimal place. So what will I do? I will look at the next decimal place. In the first case, which one is it? It is 6, and 6 is greater than 5. So I will add one number to this number, by which if I round it off to 2 decimal places, the number will become 1.75. And who is the key factor there? The digit 5. Okay. So now you tell me what will happen in the second case. This digit is less than 5. So we will neglect it, and this one will remain as 1.74. Now the tricky question, what will we do if it is exactly 5? Okay, in this case, let me tell you how the fourth one will behave. This is exactly 5. So you have to look at the second digit. Okay, this is a odd number. Okay, this 3 is an odd number. In that case, we will make it into an even number. 1.74 it will become. And what will you do if it is an even number? In the third case, you will write it as it is. So 1.74 itself. Okay. So we are making an odd number into an even number, and we are keeping an even number as such. And in these 2 cases, we are just looking whether the next digit is to where you have to round it off is greater than 5 or not. If it is greater than 5, add 1, and if it is less than 5, keep it as such. Okay, very simple. Now let's see how many significant numbers we must retain when you are multiplying or dividing 2 numbers. Let's take an example. You have 2 numbers, A and B. A is 23.73 and B is 7.23. Okay, now A by B is giving you a number with lots of decimal places. Okay, now see how many significant numbers has this A got. A has got 4 significant figures and B has got 3 significant figures. Okay, now what has happened here is a number which is precise up to 2 decimal places. 2 numbers, they are precise up to 2 decimal places, and you are dividing it and you are getting a number which is precise up to 8 decimal places. Or this one has got 4 significant figures and this one has got 3 significant figures, and the resultant has got 9 significant figures. Logically, do you think this is correct? No. So what is the rule and how the rule is behaving? The rule says, listen carefully, the rule says the resultant should have the same number of significant figures among the original numbers which has got least number of significant figures. So among this A and B, which one has got least number of significant figures? It is B and it is 3, right? So the resultant also will have 3 number of significant figures. Okay, so 3.2, and before writing this 8, you have to check the next number whether it is greater than or less than 5. It is 2, which is less than 5, so you can write 3.28 and this will be your answer. But if you are doing this process in the middle of some calculation and this is not your final answer, there is a small change, very small change In that case, you have to retain one more digit. Actually, the number of digits should be 3. The number of significant figures should be 3. You are retaining one more digit. So in that case, you have to write 3.28 and the next is 2 and the digit next to 2 is 1. So you can write it 2 itself. Right? So 3.28 will be the answer if this is your final answer, and you have to retain one more digit by which it will become 3.282 if this is coming somewhere in the intermediate stage. Okay, that's it. Now let's find out when it comes to addition and subtraction. Okay, you have two numbers, A 17.03 and B 5.7, and A minus B is giving you 11.33. Now the procedure is the same, but here the governing factor is not significant figures. Instead, here it is decimal places. Okay, so which one has got least number of decimal places? Again it is B, and that one has got only one decimal place, right? Only this 7. So the answer also will have only one decimal place, 11.3. And what will happen if this is in an intermediate stage? We have to take one more decimal place. So the answer in an intermediate stage will be 11.33. Very simple. The procedure is same, but in addition and subtraction, the governing factor is decimal place, while in multiplication and division, it is number of significant figures. That's all. Now, suppose if some constants are coming in the calculation, how many digits we have to take? That is actually purely upon our choice and the situation of the calculation. Okay, for example, if it is pi, you can take 3.1 or you can take 3.14, 141, 1415. So that is all according to the situation of the calculation. How many digits you need there, accordingly you have to take. Okay, that is the rule. Now, to determine the uncertainty when we are doing some arithmetic operations, let's take the same example that you have in your textbook. We have got two dimensions, length 16.2 centimeter and breadth is equal to 10.1 centimeter. Now, see, we have seen that the last digit, when we are measuring a value, the last digit can be uncertain, right? So in the case of length, this can be 16.3 or 16.1, breadth can be 10 or 10.2, right? So when we are writing in a method of A plus or minus delta A, we can write the same length as 16.2 plus or minus 0.1 centimeter, and breadth also same 10.1 plus or minus 0.1 centimeter. Certain people may have a doubt why suddenly this 0.1 came here. This is the answer for that. Now see, we have to find out the area. Area is length into breadth, right? And what is this 0.1 centimeter? They are the absolute errors, right? Now to find out the area, we are multiplying. So when multiplying, actually we know that absolute error doesn't have a place there, right? Then which one should be used instead? Yes, it should be the relative error. Now, so we have to convert this absolute error into relative error. And what is relative error? Relative error is delta A by A, right? So we can write this length as 16.2 plus or minus 0.1 divided by 16.2%, which is equal to 16.2 plus or minus 0.6%, and breadth similarly will be 10.1 plus or minus 1%. What is this 1%? 0.1 divided by 10.1. Now what is the area? Area is length into breadth plus or minus these two relative errors, the sum of these two relative errors, 1.6%. This is 163.62 plus or minus. Now we have to convert this 1.6% back to absolute error. This is the relative error and we have to convert it back to the absolute error. Then what will be the absolute error? This 1.6 into 6 into this 163.62, right? So this will come around 2.6 centimeter square. Now see, the length has got 3 significant figures. The breadth also has got same number of significant figures, 3. So the area also should have only 3 significant figures. So we will have to neglect this decimal part after rounding off. So this 6 is greater than 5. This will come 164 plus or minus. Now here also only one significant figure in the error part. Here also we have to put only one significant figure, which means this one will come 164 plus or minus 3 centimeter square. Now just note, only 0.1 centimeter square error in the length and breadth that has got converted into 3 centimeter square when you are multiplying the value. Okay? So now you have understood that the uncertainty is also dependent upon the number of significant figures. Now see, here for both the length and breadth, the uncertainty or the error, the absolute error is 0.1, right? Both are same. But here when it comes to the relative error, their value has got changed. One is 0.6 and another is 1. Why? Because although the delta is same, this A has got a different value, right? At one point it is 16.2 and in the second it is 10.1. So the relative error has changed accordingly, which changed the error in the area also. Now that is the second point which you have to note. The relative error is dependent upon not only the significant figures but also on these two original values, and that is the second point which you have to note when you are determining the uncertainty while you are calculating the arithmetic operations. Hope both these points are clear for you. So friends, let's call it a day. And I will be coming with another new fresh topic, and believe me, that will be the most interesting topic in this unit. Until then, Rishi signing off. Bye. Take care. Jai Hind.